It's a sunny morning today, and I was going to show you guys the spray bar part of my aquaponics today. I drilled all these little holes into this PVC spray bar in hopes that it would aerate the water here for the fish. I don't have any fish in it right now. They are in the house. It's springtime here. The water's warm enough for the fish, but the water is still a little murky. I'm hoping to clear it up. I just started running the pond for this spring, running the pond pump, but I don't have a lot of plants in my aquaponic bed because it got to 19 degrees this winter and they all died. I've got some basil coming out, sprouting out from last year, and surprisingly a couple tomato plants made it this winter in my aquaponics bed, so I'm trying to encourage them to come back. Unfortunately, I actually didn't plant any seedlings this year, but I think I'll have enough from seeds, basil seeds that sprout up in my aquaponics bed, and others that get this thing started and up again. The water's starting to clear. It used to be very murky, but it's settled down, and as long as the plant's roots start to filter this water, we'll see in the next video if it gets cleaner. So let me go over the spray bar though. Originally I drilled a bunch of holes in the spray bar to aerate the water, and the algae just took over all the holes and clogged it all up. So this used to be connected to here. You know, it was a shorter pipe, and this pipe just came and ran straight across. But finally I cut it just to let the excess water come out into the water because it just got plugged up with algae. It wasn't such a bad thing though. It turned out to be a much better design because you see these two wires in here? There's two wires in there, and they detect the water coming out from the pond pump. And if those wires are not connected through a channel of water, the conductivity goes down and the microcontroller will turn off the pump. Watch. I take one of the wires out. See, the pump turned off because it noticed there's no water flowing anymore, which is exactly what I want it to do, because if you run the pump dry, it will burn out your pump. I get these pumps from eBay. They're like $13. They come from China. Let's go see what the microcontroller is doing. So the microcontroller is saying dry pump. It's got a digital readout of 513. That is the analog read value of the water probe. And if it goes below about 425, the pump will turn on again. Since I put the wire back into the water flow, maybe I'll catch it when it tries again to turn on the water and detect the water. Now, if that water probe, those two wires, are dunked in the water, this microcontroller will also sense that it's dunked in the water, but the pump is not turned on. And in that case, it will never turn the pump on because it knows that it can't detect the water flowing because the probe has been dunked in water. This sometimes happens when the probe gets algae on it and the algae spans one electrode to the other. So it's smart. It knows. I'll try every, I think it's 2 minutes to turn on the pump and check the water probe, and if the probe detects water, it will stay on. But if the pump is not on and it detects water, it won't attempt to turn it on in the first place. Let's go see. So those are just Ethernet Cat5 cables that I stripped, and every now and then I have to kind of scrape the corrosion. Okay, so the pump just turned on, and Water hasn't gotten to the probe sensor yet, but you can see it's starting to drip out the low end over here. And as it reaches up to the high end, we can go see what the pump controller is reading now for the analog to digital in value of the probe. So the probe is reading 256, which is well below the 425 resistance reading without the water. So it turned the pump on. Solar panels reading 16 volt. And the uptime, that's the time that I track. It shows how long the pump has been on, actually how long the microcontroller has been on since the morning sun rose. And I'll describe what all these other values are later. But I guess that's enough for now. Talk to you later. Bye. Mentioned reasons the pump could go dry in an aquaponics situation. I burned out 3 pumps without having that detector on the water coming out of the hose, and the main reason was either the actual water evaporated, which happens surprisingly frequently. I wasn't aware of how often you have to refill these aquaponics. Even though they save water, a lot of water is transpired through the leaves and just evaporates in a greenhouse. Also, the pump could get plugged with any debris that makes its way into the sump pump. It could clog the pump, and then the water would not exit this spray bar, and it would be detected and turn off the water. Let's see. I think that's about it. Sometimes the pump is halfway dunked in the water. It still means there's not enough water in the sump pump, and you shouldn't run the pump if it's not fully submerged in water to keep it cold. But since I had this detector on, I haven't really burned out any pumps. The pumps are only like $13, but they take a long time to get here. I ordered them from China. They're cheaper, and they seem to do a good job on the 12 volt solar panel.